Measurement of segments, Level 4. In this last video on measurement of segments, we will go over two challenging examples involving congruent segments and plenty of algebra to solve. Let's go ahead and try the first example. The perimeter of PRST is 10 more than 5 times the length of segment RS. If the length of segment PR equals 26, find the length of segment RS. In this problem, we are provided with a figure that has 4 line segments. We are asked to determine the length of segment RS. Notice that the figure contains 2 line segments with matching single tick marks and 2 line segments with matching double tick marks. These marks tell us that line segment TS is congruent to line segment PR, and that line segment PT is congruent to line segment RS. We are also told that the perimeter of the figure is 10 more than 5 times the length of segment RS. We can translate this fact into an equation as the perimeter equals 10 plus 5 times the length of segment RS. We are also told that the length of segment PR is 26. This means that the length of segment TS is also 26, since both line segments are congruent. Next, we need to determine what our unknowns are. In this case, we are trying to find the length of line segment RS, so we will represent this length with a variable x. Since line segment PT is congruent to this segment, we can also represent the length of segment PT with a variable x. Now it is just a matter of finding a variable expression representing the perimeter of the figure. In this case, the perimeter will be equal to the sum of the lengths of all 4 line segments. Now that we have this relation, let's substitute the numerical and variable expression for each line segment. Then, we simplify the expression by collecting like terms. Doing that, we obtain the following variable expression for the perimeter. The last step is to set the variable expression representing the perimeter of the figure equal to 10 plus 5 times the length of segment RS. Recall that the length of segment RS can be denoted with the variable x. From here, it is just a matter of solving for x. Doing that, we obtain x equals 14. And this is the length of segment RS. It is important to use geometric relations and algebra together when solving many of the problems that you will encounter in this course. This is why it is important to understand both the geometric concepts and that you are well versed with algebra. Alright, let's end the video with a final example. Given that line segment AD is congruent to line segment CB, line segment AC is congruent to line segment DB, the length of segment DB is equal to 2R plus 5, the length of segment AD is equal to 3M plus 7, the length of segment AC is equal to 3 1/2 R plus 2, and the length of segment CB is equal to 4.2 M plus 5. Solve for the variables R and M. In this problem, we are provided with a figure that contains various line segments. We are also given various geometric and algebraic relations. We need to use these relations to solve for the variable R and M. Let's first take a look at the geometric relations. We know that line segment AD is congruent to line segment CB. So let's draw single tick marks on these segments on the figure shown. We also know that line segment AC is congruent to line segment DB. So let's draw double tick marks on these segments. Now that we can visually see which segments are congruent, let's figure out a way to solve for the variables R and M. We know from the given information that segment AD is congruent to segment CB. This means that their lengths are equal. In other words, the measurement of segment AD is equal to the measurement of segment CB. Since we have an algebraic expression for the length of each segment, let's go ahead and set these algebraic expressions equal to one another. Notice that we now have an equation with a single variable m. So we go ahead and solve for m. Solving for m, we obtain 5/3. We now do the same for segment AC and segment DB. Equating the algebraic expressions and solving for r, we obtain 2. So r equals 2 and m equals 5/3. It is important to set up the geometric relations by using the information given in the problem. Once this is done, it is just a matter of using those relations to solve for the unknown variables. Alright, and this ends the measurement of segments series. In our next series of videos, we will focus on measurement of angles.